we need to evaluate this integral having this integrand over the circle C, where C is the circle mod z equal to 2. So what points we are getting by taking this denominator equal to 0? We need to get the poles, right? So when taking this denominator equal to 0, we get z equal to 0, z equal to -1, z equal to +3. Now which of these points lies inside this circle? Z equal to 0 and z equal to -1. Only these 2 points lies inside this circle, and the point z equal to 3 lies outside the circle, right? So we need to calculate the residues for these 2 points only which are lying inside the circle, and then we apply the residue theorem to solve this integral. So let's start with the solution. So we are having this function, and now to get the poles, we take the denominator equal to 0. We get z into z plus 1, z minus 3 equal to 0. We get z equal to 0, -1 and 3, right? So we have got the simple poles because the power is 1, right? Whenever the power is 1, we have the simple poles, the pole of order 1. So Fz has 3 simple poles at z equal to 0, -1 and 3, right? Of which only z equal to 0 and -1 lies inside the circle. The given circle mod z equal to 2. So first we calculate the residue at z equal to 0, and then we calculate the residue at z equal to -1. So finding the residue at z equal to 0. So that is limit z tending to 0, z minus 0, f of z. Z minus 0 is z. So this is limit z tending to 0, this is z, writing the function. So this is 2z minus 1 divided by z into z plus 1 into z minus 3. Z cancelled out, and putting z equal to 0 over here, we get -1 in the numerator and 1 into -3 in the denominator, that is 1 divided by 3. So the residue is 1 by 3 for z equal to 0. Let's find out the residue at z equal to -1. So the residue at z equal to -1, this is limit z tending to the point -1, and writing z minus this point. And because it is your simple pole, the power should be 1 here, right? Here also the power is 1 because z equal to 0 is a simple poles, pole of order 1, f of z. So this is limit z tending to -1, this is z plus 1, and writing the function 2z minus 1 divided by z into z plus 1 into z minus 3. So these two cancelled out, and by putting z equal to -1 over here, we get 2 into -1 divided by -1 into -1 minus 3. So that gives -2 and -1, that is -3. And in the denominator, this is -4 into -1, that is 4. So we get -3 divided by 4 to be the second residue at z equal to -1, right? And now we apply the residue theorem to evaluate the integral, the given integral. So by residue theorem, the given integral is equal to 2 pi iota times the sum of the residues. So this is 2 pi iota times, what is the first residue we have got? It is 1 by 3, and then is -3 by 4. So this is 1 divided by 3 plus -3 by 4. So that is 2 pi iota into, taking the LCM, This is 4, then minus 9. So this is 6, and this is pi iota minus 5 divided by 6. That is minus 5 pi iota by 6 is the required answer for the given integral. Okay, thank you.